Hello everybody, we're going to do a quick video on scientific notation. So first, this is a solution to a problem. So let's start by looking at the problem. In science, we sometimes have very big numbers. For example, the mass of planet Earth is 59720000000000000000000 kilograms. And I barely fit it on the page here. Okay, this is a ridiculously large number. Hopefully you're realizing, okay, we got 4 digits here that matter, and the rest of these are all zeros. Are they actually zeros? Probably not. They probably have values that go in here, but we've just rounded it to the nearest, whatever that 2 is, 2 trillion? I don't even, way past trillions. I don't even know. Okay, we have these huge numbers, way too big. We don't have words to talk about these numbers that are this big. So how do we handle this? This is the problem. The solution to this problem, actually, we're going to take advantage of 2 math principles. Real quick, if I take a number, let's say I take 3.7, and I multiply that number by 10, then I get the same number out, 3 and a 7, but instead of being 3.7, now it's just 37. Okay? Or if I have 15 and I multiply that by 10, I get 150. Do you see what I'm saying? The number stays the same when you multiply it by 10, but we move the decimal point over 1 spot. In this case, I took it and moved it over 1 spot to get 37. 15, well, the decimal point is right here. If I move it over, I've got to add a 0 to make up for it. Okay, this is the first principle. Multiplying by 10 moves the decimal point over 1 place. And of course, that means that the opposite must also be true. If I have 3.7, back to 3.7, and I divide it by 10, or do you prefer this symbol? Divide it by 10, then I move the decimal point again, but it goes the other direction, so I get 0.37. Okay, so multiplying it by 10 moves the decimal point to the right, and dividing it by 10 moves it to the left. Okay? And the second principle that we're going to take advantage of is if you do something multiple times, if you multiply something multiple times. So let's say I take, I don't know, 5, just some number, multiply it by 2, and multiply it by 2 again, and multiply it by 2 again. Well, I'm doing this 3 times. I can simplify that to just be 5 times 2 to the third. Okay? So if you multiply something multiple times, you can simplify that by putting it to an exponent. Okay? And the same thing goes for dividing. If this was 5 divided by 2, then the effect would be 5 times 2, not to the third, but to the negative 3. Okay, so multiplying it makes it more positive, dividing it makes it more negative. Okay? These are the only 2 rules we need for this. So the solution is, going back to our big number, we can't have numbers this big. What we want is we'd rather have a number that's small. So we want a number between 0 and 10, or 0 and 9.9, I should say. And the way we do that is we move the decimal point right here. So now my new number is 5.972 kilograms, right? That's the mass of the Earth, right? Wrong. The Earth is not just under 6 kilograms. So we have to somehow deal with all of these zeros. And how are we going to deal with that? Well, same thing. If we multiply by 10. If I take this number and multiply it by 10, I get 59. Multiply it by 10 again, I get 597. Multiply it again, 597 or 5,972. The question is, how many times do I need to move the decimal point to get this big number? And I have to count. So right here, the decimal point's right here at the end. I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I'm going to multiply it times 10, 24 times. If you type this into your calculator, let's do that. Here's my calculator. And if I type in my calculator's not on. 5.972 times 10 to the 24th. Oh, wait a second. Is that what we want? 5.972 E24? Well, let's type in the other one. 5 972 and count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Push enter, you get the same thing. Okay, so the calculator doesn't like all these zeros either, so it's also taking the same shortcut, except for it's doing it slightly different. That little E there, you've probably guessed it, that E means times 10 to the. Okay, so we said the answer should be 5.972 times 10 to the 24th. They said 5.972 E24. So that's what this means. It's just that in quotes. Okay. So yes, in other words, if I type in 5.972 times 10 to the 24th, this is what the calculator does. And that's the exact same as if I just typed in the whole number. So the calculator sees these two numbers as being the exact same thing. And if you don't believe me, do the math yourself, check it. It should be the exact same thing. So this is a shortcut way of writing our big numbers. We just write it like this. Hopefully this isn't too bad. Let me show you a different kind of example. What if instead of being a big number, what if it's an incredibly small number? So we've got this number. This is the wavelength of light for purple light. So this is, if you measure the light waves as they fly past, this is how big they are. This one is 0.000, I got to count, 1, 2, 3, 4, 5, 6, 4 meters. Okay? Okay, this is an incredibly small number. It's the exact opposite of our last problem. Our last problem was so big it took up too much room. But you can see even small numbers take a lot of room to write them as well. So how do we handle this? Same thing. I've got to get the decimal point right after that first number. So I want 4.0. I implied a 0. There's a 0 implied after this. I wrote it because I like to be more precise. You don't have to write it. Times 10, because that's how we do it, to the what power? Well, let's count. 1, 2, 3, 4, 5, 6, 7. I got to move it 7 times. So it's going to be to the 7th power. Now, hopefully you're yelling at the camera saying, no, you forgot something. Well, we moved it down to make a small number instead of moving it up to make a big number. So it's got to be -7. That negative means very small number. If it's a positive number, that's a huge number. If it's a negative, that means it's a small number. Okay? And this is how we do scientific notation. Now, also in this video, what I'm going to do is I'm going to put a few into my calculator because this is where students really have the hard time. Most students get this after a little bit of practice. But this is where students really have the hardest time. So let's do on the calculator. Let's do a few more. Well, let me just type in this number. 0.000, there's 6 zeros. 1, 2, 3, 4, 5, 6, 4. If I push enter, look at that. My calculator already figures out 4E7. 4 times 10 to the 7th. We agree. Now, what if I want to just skip right ahead? If the calculator is going to use the E's, can I use the E? And the answer is yes, you may. So if I do 4, and if you notice, can I get that right in frame? There's a 2 E's right here under that button. Since they're in blue, I have to do second, and then I can do E. And then I can type in my -7, and there we go. It works. Now, every single calculator is different. So I have this one. Whoops. And you see, it's also got those 2 E's right under my finger, get in focus. So that's another one where I'm going to push second E. This one is actually a little different, so I'll show you. 4. Oh, it's not on. 4 E -7. Right, I can do it that way. But notice how, it wrote out the whole number for me. It doesn't want to do it in scientific. Let's do the other number. The mass of the Earth was 5.729 E24. And I'm trying not to get the glare on the screen. Notice how it just rewrites the number, and then it puts the 24 over here on the side. Okay, so you got to pay attention. Practice this on your calculator. See how your calculator handles it. Those are both Texas Instruments. Here's a Casio, and this one's actually pretty easy. 4, and it's got this button here that says EXP. That stands for exponent. And then I could type in our -7, and there it is. That's how the Casio handles it. So whatever calculator you've got to play around with it and figure out how your calculator can handle it. But that is a common mistake. Students don't know how to do it. Here's another common mistake. If I take a number, 1, divide it by a big number, doesn't even matter what it is, I'm going to get a very small number. See, e to the negative, that means it's a small number. So if I take 1, divide it by 5, I don't know, 36, that's a huge number, but it's 1 over that number. So we should get a small number as our answer. And there we go, 2e negative 37. Okay, that's exactly what we expected. But what if I don't want to use the e's, or I don't know how to use the e's? Can I do 5 times 10 to the 36? Is this going to work? And the answer is no. But there's an easy fix. It does work if you know what you're doing. So let's bring that back. Here it is. If I put parentheses around that number, and 1 in the front, insert a parenthesis. Okay, so now it's the same exact problem, but now it's got a parentheses. Notice it's 2e negative 37, just like we did the first time. So if you're going to write it out the long way, that's totally fine. Your calculator can handle it just fine, but you've got to put parentheses around the number so it knows, oh, we got to do this first before we do the division. So that's just order of operations. So I have here, let me write a few more on here. What I want you to do, if you're still feeling a little bit shaky about this, go ahead and try to answer these. And then if you get the answers, I'll put the answers, I'll put them in the description for the video so you can check your work. So here's a few that I want you to put in, see how you're doing. We've got 300, I gotta count the zeros. Okay, that's the speed of light, meters per second. If you want to know, that's the speed of light. Try doing that one. This one is the distance from the sun to the earth in miles. Okay, so this is 1, this is 2. That's a very big one. Let's try it. This is number 3, 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 1, 6, 7, 2, 6, 2, 1, 9. That is the mass of a proton, kilograms. I don't know if I got those zeros right. I'll make the answer to what I wrote, not what the real answer is, because I want you to practice this and not worry about the number. We already did the wavelength of light. Here's my favorite number, 14. Can you put that in scientific notation? You can. Number 5, let me just move the camera down a little. Number 5, let's do, here's just a random number, 0.000020001. And here's Coulomb's constant. This is a number we're going to use in our physics class. 9 billion. Did I get the right number of zeros? There we go. Okay, so there's something you can try. I'll put the answers in the description. If you're feeling good about this, great. Just double check your work. Try typing these in your calculator. Make sure you try it yourself. Don't just trust that you know what you're doing. Actually try it and see how you do. Thanks, everybody.